Okay, this is my problem set for week 6 of Calc 2. We're going to start on number 1, which we found out is 1 over x squared minus 4x minus 5. You can separate that into two separate parts over here, and then you do that and start using your partial fractions. After multiplying the bottoms by the reciprocals over here, you get your top 1 equals ax plus 1 plus bx minus 5. If you plug in -1 for x, you get a times 0 and b times -6. Divide 1 by -6, you get b equals -1/6. Same for when you plug in 5. A becomes a times 6. That is because 5 plus 1 equals 6. And then b becomes b times 0 because b times 5 minus 5 equals 0. So a is 1/6. Then down here, you use the integral, or you find the integral of 1/6 x minus 5 using u substitution. U equals x minus 5. Over here, go through the work. Blah, blah, blah. And then basically the -1 ends up exactly the same, except for you plug in x plus 1 for your u substitution instead. And then the derivative of x plus 1 is obviously just 1, and then dx. So easy plug-in. Final answer. Second, evaluate 1 over x times x squared plus 1. Make that equal a over x plus bx plus c. That's because you have x squared over here, so you have to account for that. 1 equals, after multiplying them out, a times x squared plus 1 plus bx plus c times x. This is some work I did that was wrong, so I scribbled it out. And then after multiplying it out, you get ax squared plus a plus bx squared plus c. Then you can combine like terms to simplify it. 1 equals a plus b times x squared plus c times x plus a. At x equals 0. This equals 0, and this equals 0, so all you have left is a, so a equals 1. You plug in a equals 1 to get 1 equals 1 plus b, x squared plus c, x plus 1. Then to make both sides equal, b equals -1 and c equals 0. Then you plug it in to get 1 over x minus x over x squared plus 1. There's nothing after the x because the c equals 0, and it's only a single x because b equals 1. Then you find the derivative of, or not the derivative, the integral of both sides. Finding that 1 over x is voila, ln x, or natural log x. And then the integral of x over x squared plus 1, use u substitution, u equals x squared plus 1. That makes du equal x dx. So again, very easy to solve after using u substitution. You get the same ln answer, plug back in x squared plus 1, and then there should actually be a plus c here. I just forgot to write it, so please don't deduct points. And then lastly, moving on to number 3. It's a little organized wrong, but yeah, my first attempt at 2 was wrong because I thought that was a perfect square because I'm stupid. But number 3, 1 over x minus 2, x plus 5 squared dx. You can separate that out. You have to account for both parts of this variable, the square and then the inside the square. So then you get 1 equals x plus 5 squared plus b, x minus 2, blah, blah, blah. And then you plug in x for 2 to get a times 7 squared. I didn't write the rest of it because the rest just equaled out to 0. And then 1 equals a times 49th, making 1/49th equal a. X equals -5. Plug it in, you find that the only thing that works out is -7c, so therefore c equals -1 over 7. And then lastly, you plug in 0, and then you get 1 equals 25/9 plus b. This is also plugging in your other values that you've already found. So you get 1 equals 25/9 plus b times -2 times 5 plus 2 over 7. There's 2 pluses there because I accidentally wrote a minus at first. Then -10b equals 7 minus this number. -10b equals 10 over 49. b equals -1 over 49. Kind of see the 7 relationship here. And then using u substitution like every other time, the du is kind of inconsequential here. It just always equals dx. You solve it out, plug it in, blah blah. Yet again, we get a ln answer with u substitution, with the 1/49 being pulled out ahead of time. And then we get our final answer of this, and I meant to draw an integral sign here, but I also forgot. The integral of this equals this plus c. Did not forget the plus c. Please enjoy.